Hi, Honors Chemistry. I'm going to give you a little mini lesson today on the gas laws, and then that'll help you solve some homework problems. So the first thing I want you to know is that we're going to be using the PowerPoint called Gas Laws Notes from 2016. All right, so you need to familiarize yourself with slides 2 through 13. And I'm going to kind of talk about some of those slides, so you might want to have that open while you're watching this video. Okay, the first thing to know is that there are 4 variables that affect gases. One is pressure, another is volume, another is temperature, and the fourth one is the number of molecules of the gas. And so today we're going to focus on these first 3. And we're going to create some equations that you can use to solve that allow you to relate one variable to the next. So first, let's just talk about a couple of things with pressure. If you look at slide number 6 on that PowerPoint, there's information about it. Okay, there's different units of pressure. The most common units are atmospheres, and another one called kilopascals, and another one called millimeters of mercury. All right, it measures the height of a column of mercury, and you can convert between the two. So, for example, 1 atmosphere is equal to 101.3 kilopascals, which is equal to 760 millimeters of mercury. And so we can convert between units just like you're doing stoichiometry. Okay, when you're referring to temperature, look at slide 7, and often we use Celsius, but in gas laws, we're going to use a temperature called Kelvin. All right, and the conversion is 0 Celsius is equal to 273 Kelvin. So what you do is you just add 273 to each Celsius temperature in order to convert. And so we have to use Kelvin for all the problems. And so if the problem gives you the temperature in Celsius, you have to convert to Kelvin before you plug in and solve. Okay, if you use Celsius, you'll get the wrong answer. And volume, we typically use liters, but we might use milliliters, and 1,000 milliliters equals a liter if you had to convert. So there are some simple gas laws. So if you're looking at slide 10, there's a law that deals with pressure and volume. It's called Boyle's law. And what it allows you to do is calculate the pressure and the volume at before and after. So if you look at a problem, it might give you the before conditions, and it might give you one after, like before and after, and then you solve for the unknown variable. So like there'd be 3 numbers in the problem, and you plug 3 of them in, and you solve for the 4th one. Okay. If you advance to slide 11, there's a slide that deals with volume and temperature. And these have a direct relationship, and you can show that with dividing. So the volume versus the first temperature is equal to the volume, the second volume and the second temperature. Okay, and then if you move to slide 12, there's another law that deals with pressure and temperature. Again, you have before and after, okay? And there's some overlap here. So pressure and volume, volume and temperature, pressure, temperature. We can put all of them together into what's called the combined law, which is described on slide 13. It's called the combined law because it combines them all. So we have P1 V1 over T1 equals P2 V2 over T2. And this problem will be a little bit longer because maybe you'd have 5 numbers in the problem and you solve for the 6th, the unknown variable. So you need to look at these slides and kind of get familiar with the options and what the units are. But I'm going to run through a couple practice problems with you to help you with your homework today. So if you look at slide 14, it says which gas law. And so problem number 1 talks about you have 30 liters of oxygen in a tank with a pressure of 1.2 atmospheres, and then the pressure is increased. What will be the new volume? So the first problem deals with 30 liters and 1.2 atmospheres, and then it moves to 1.5 atmospheres, and it wants to know what the new volume is going to be. So here you have volume and pressure, and so we're going to use the equation with pressure and volume. So if you were to solve it, you would use that equation right there, and so these are your ones. So you would have 1.2 atmospheres times 30 liters equals 1.5 atmospheres times an unknown volume. And so you would multiply these together and divide. And so as you do that, you'd multiply 1.2 times 30 and then divide it by 1.5 to solve for V2, and it would come out with 24 liters. Okay. If you look at slide 14, number 2, it says a 2-liter box of nitrogen at 100 Kelvin. So we have 2 liters and 100 Kelvin. And then it moves to 200 Kelvin, and it wants to know what the new volume is going to be. So this time we have a volume and a temperature, and so we need to use the equation with volume and temperature. So you would plug them in. You would have 2 liters over 100 equals your unknown volume at 200. And here you'd cross multiply. So you'd cross and then divide. And so when you solve for that, you'd multiply 2 times 200 and then divide by 100 to isolate the variable, and it comes out to 4 liters. Okay, so what you're doing is, as you read the problem, you're trying to match up the variables to the equation that you need to use. Okay, I'm going to slide ahead really quick to slide 17 and do one more problem. And if you look at the third problem on there, it says the gas has a pressure of 103 kPa and a temperature of 80 Celsius. Okay. Now, to do this problem, we're going to have to move that into Kelvin. Okay. And then if you keep reading, the can is placed into a freezer, so the new temperature is, I looked at that wrong. This is 25 Celsius, and then it's negative 80 Celsius. But the point is that we're going to need to move these into Kelvin in order to solve it before we plug it in. So to do that, I'm going to get a new piece of paper here. All right, so again, that problem number 3, we're going to have to do 25 Celsius and add 273. So when you do that, you get 298 Kelvin. And then the negative 80 Celsius plus 273 is going to be 193 Kelvin. So these are the numbers we have to use. If you can't use Celsius in the problem. All right, so we're going to need to use the equation with pressure and temperature. So that's P over T equals P2 over T2. So the initial pressure is 103. The initial temperature is going to be 298. Again, you have to use Kelvin. You cannot use Celsius. And we're going to solve for the second pressure. when the temperature drops because it's in the freezer. All right, so you'd cross multiply and then divide. So you'd have 103 times 193 equals P2 times 298. If you divide both sides by 298, P2 comes out to, let's see, 103 times 193 divided by 298. The new pressure has dropped to 66.7 kPa. Okay, and finally, if you did the combined gas law, like if you advance to slide 20 and look at problem number 2 on there, we have a pressure of 501 and a temperature of 25, and the volume is 5.2, and then it's heated up, so the new temperature is 100, the new volume is 7, and it wants to know what the new pressure is going to be. Okay, so this is going to be this combined gas law where you have to use all the variables. Okay, and so before I plug in, I'm going to convert these to Kelvin. So I'm going to add 273. So this is 298 Kelvin. I'm going to add 273. So this becomes 373 Kelvin. And these are the numbers I'm going to use. So P1 V1 over T1 equals P2 V2 over T2. Let's plug all these numbers on the left. So we have 501 times 298 over 5.2 equals P2, that's the variable we're solving for, 373, 7. Okay, you're going to cross multiply. So the ones opposite each other multiplied equal the other side. So 501 times 298 times 7 equals P2 times 5.2 times 373. I dropped all the units just for simplicity, so that the algebra wouldn't confuse you. But basically, to solve for this, we're going to divide by 5.2 and divide by 373. If you divide both sides by that, then when you solve, you should get 465.8 kPa. Okay, notice you have to use Kelvin. If you use the Celsius temperatures, you'll get the wrong answer. Okay, hopefully that helps you with your homework tonight. As always, email me or send a message to the Google Hangout that we have set up. And good luck and have fun with these gas law problems.